Good morning and good evening, everyone. Today we are going to talk about MLOps, and we are going to talk about how to set up an automated CI/CD pipeline for model deployment. So before we get started on the session, just a quick intro to my channel in case if you are new to my channel. So my channel name is AI Engineering, and that's how you landed here. If you want more details on the courses and also what kind of materials are available in my channel, you can go into my GitHub repo. My GitHub repo is github.com/srivatsan88. You can go into the repo and I have listed out all the courses that are available in my channel. The courses are completely free and I cover to a lot of detail. I have courses on Google Cloud AI, end-to-end time series, Apache Spark, and a lot of courses. If you scroll down, you will see information on different projects you can build on machine learning. You can also see playlists that contains specific tasks that you can build. So that's about my channel. Now let's get back to what is this today's session about. So today's session, we are going to talk about MLOps. We are going to build an automated CI/CD pipeline for continuous deployment. And what are the topics that we are going to cover today? So what we are going to do is we are going to first train an image classifier model. This will be a simple image classifier model. See, the purpose of this session is to show an end-to-end demo and not really go into the details of each and every component of it. Each of this is by a big session by itself. If I start covering it, it will take weeks to cover. So I'm going to condense it as much as possible. At the same time, give you all the details that you can work it on your own. Then I'm going to create a Streamlit web application of the trained model that we are built. Finally, once I have the Streamlit web application, I'm going to do an automated build script. So typically what happens when you deploy a model, you need to take the model, you need to kind of integrate with your GitHub repo, you need to package it, you need to put it on either a serverless environment, or you need to basically put it on a Kubernetes environment. Or it can be your own virtual machines or physical infrastructure. So we are going to see how we can automate the build process. I'm going to manually trigger the build into Kubernetes. And then I'm going to do a GitHub integration and finally show an automated CI/CD pipeline. We will have the Q&A towards the end of the session. So I'll go on with the session with my flow and finally take up all the questions that are there, or whatever amount of questions is possible. Because sometimes I have seen the questions go for hours. So I'm going to time box this particular session to 1.5 to 2 hours. And anything more than that, I will try to answer it post the session is live. So let's get started. Let's first go to our topic of building a model. I will go to the different slides later, but let's first build the model. So for this purpose, I'm going to build an image classifier model. The image classifier model, I'm going to use the leaf disease classification data set. This leaf disease classification data set is available in Kaggle. Let me go to full screen. Yeah. This leaf disease classification model is available in the Kaggle for you. You can download it, or you can download from the URL that I have given over here. So I'm going to import Tensorflow. I'm going to use Tensorflow for this purpose. I am going to use a pre-trained model. I'm going to do transfer learning. For that, I'm using TensorFlow Hub, Matplotlib for visualization, and NumPy is just for processing the data for serving. So these are the packages I have imported. This IPython display is nothing but a utility function that can be used to basically visualize the data inline in your Collab notebook. So that's why I've imported this IPython.display. Okay, so while this package is getting imported, I want to make sure I have an GPU available. If you don't have GPU also, it's fine. You can run this on CPU. It's just a transfer learning task. But if you are in Collab, just make sure your runtime, you can go to runtime and change runtime and put it as GPU. If you don't have GPU also, it's completely fine. Okay, this is going to take just few minutes more. Other than that, you'll still be able to run the model. So I'm just checking. I have a GPU. I have a Tesla K80 GPU over here. Now, the data set that I'm going to download is available in this particular link. It's basically available in the Google Drive. You have the train, validation, and test data set. This is also available in Kaggle. You can just check for leaf disease classification data set in Kaggle, and you will find it. Right. So I'm just downloading it from here. The reason I am using and downloading it and doing it, there are two ways to import a data set in TensorFlow. You can use TensorFlow datasets. TensorFlow datasets also has this particular data set. But once I use a TensorFlow data set, putting your own data set becomes difficult to understand. So I just want to keep it very generic so that you can import your own data set and play around as well. So I have downloaded this 3 particular data set: train, validation, and test. Okay, now let me go and create a directory called beans, where I am going to unzip all this particular 3 data sets that I have. So I'm just creating a directory, and then I'm unzipping the train, test, and validation and putting it into the beans directory that I have created on the top. Okay, let me, after this unzipped, let me quickly do an ls, and let's see like how the folder structure look like. Now there are 3 folders. That is test, train, and validation. And if you go into the internal folder, right? For example, if I go into beans.train, you will see one folder for each classes. This particular data set has 3 classes. One is a healthy class, which is telling the leaf does not have any disease at all. The other 2 basically you see is like an infected leaf. So basically one is the angular leaf spot, second is the bean rust. These are like bean leaves, and what kind of, whether they are infected or not infected. If they are infected, what is the infection type, whether it's angular leaf spot or bean rust, or if it is healthy. Okay, so this is how it looks like. And basically I have 3 folders over here: train, test, and validation. Now, why I'm this folder structure is very important, because I'm going to use Keras read from directory. And what the read from directory does, it takes your internal folder structure as your classes. So it when I configure this train directly, it's going to understand there are 3 different classes of this, and that's how it's going to basically take and generate the data set for object for us, TensorFlow data set object for us. Okay. Then next, what I'm going to do is I'm just going to do the count of images. Okay, now for example, this beans, how many images are there? In total, there are 1296 images. And in the test, basically, I have 128 images, and in the validation, I have 133 images. So how many images I have? Now, I don't have a lot of images, but I don't have very less image as well. So what I can do is this particular task, I can either build my own custom CNN model, or I can use transfer learning, or I can use fine tuning of an existing architecture. These are 3 different options available. Now that option also determines on what kind of data set you have. So I will come to that, but these are the 3 options available to me. Now let me quickly visualize some of the images in different categories. So what I'm doing is I'm using the utility function that I imported. Okay, for example, like I am using the image class, which I imported from IPython display, and I am visualizing the LT class, how it looks like. So this is the bean leaf. This is the LT class. So this does not have any infection. You can see the leaf is pretty clean. Let me do one angular spot also as well. So if you see angular spot, this is the angular spot images, and you can see basically the leaf has like kind of bigger spots over here, and this is the angular spot images. And finally, what I'm going to do is I'm going to visualize the bean rust as well, and this is the bean rust. Okay, now I have 3 train, test, and validation. But when I'm going to do inference, I'm going to pick a completely new data set from internet, and I am going to kind of show you how the inference looks like. And the idea is not about the model accuracy and everything. It's just to show you an end-to-end pipeline, but we'll build a decent enough model which is fast enough for us to do. Now, the next thing I'm doing is I'm setting some of the parameters. What is the batch size I have? So in each epoch or each iteration, how much of batch of data I want to pass? What is the image item width? The image item width depends on multiple factors. Either when you are developing a custom model, you can define a custom item width. If I am using a transfer learning model, I need to make sure my item width matches the model architecture. So if I'm using an Inception v3 model, I need to make sure my Inception v3 model input image size matches whatever input image I'm passing. If I'm using a mobile net model, it should match that mobile net model. Okay. So that's what I'm setting over here, image item width. For me, I'm going to use a pre-trained MobileNet v2 model, and that requires the image to be of 224 and 224. That's why I'm giving 224, 224. So these are the 3 parameters I'm setting. Now, if you see on the top, I have 3 directories. I have the train, test, and validation directory. That's what we have seen, right? 3 directories we have, the train, test, and validation directory. Let me go over here and print it. Okay, now I need to take this directory and I need to kind of create an internal array of images that I can feed into my model. And I'm using TensorFlow latest version 2.4. Just make sure you are 2.4 to run the above program. You can also run it on previous version, but there's a small change that is required if you want to run it on 2.1, 2.2, 2.3. I will tell you what change it is. TensorFlow 2.0 basically includes your pre-processing pipeline also as part of your TensorFlow graph, and that is very advantageous because you can take a single model object and deploy it in production. If you're using previous version, there will be a pre-processing step that will be separate that you need to just embed it, and that's not a big deal. It's just a small difference for the work we are doing here. But I will tell you what it is. So what I'm doing now, I have the 3 data set. I am using the TF Keras pre-processing image data set from directory. So what it will do is it will read the images from the directory. It will resize the images with the height, and it will also batch the images, and it will finally give me an TensorFlow data set. Okay, so that's what it's going to do. So I have 3 of it. I'm creating one for train DS, test, and one for validation. I have 3 directory. For each directory, I am creating a TensorFlow dataset or TensorFlow Keras dataset in this case. So finally, the way TensorFlow dataset works is finally the TensorFlow requires a TF data API. So the Keras pre-processing is going to make it compatible so that we can feed it into the model. Okay. Now I have the tensor train DS, I have test DS and validation DS. So I have three data set objects that are there, one for each directory: train, test, and validation. The train and validation I am going to use during the training process, and a test is something I'm going to use during the kind of the validation process, right? Like how my model is performing on an unseen data set. So these are the 3 data sets I have. Now, let me quickly kind of print the data set. So what I'm doing is I have train DS over here. I'm just iterating in train DS. You can do a lot of things once you have an Keras object. You can quickly iterate it. You can print the image. You can see the image. You can go and verify it. So I'm just just showing you an example on how you can manipulate the train dataset object. So in the train dataset, I am reading the image batch and the labels batch. The labels are determined by the directory structure. I showed you basically there is an directory structure on the top. Basically, the images are determined by the directory structure. So once I run this, it's just going to print some of the images over here. You can see basically the image is of type 224, 224, and there are 3 channels, and that's what we had given on the top. And then 128 is the batch size. So each batch of images will have like 120. Each batch will have 128 images, and the label is 128. Okay. Now, the next thing I'm going to do is I'm just going to print the class names. What are all the different classes available? And you need this classes available because your model is not going to print the classes for you. It will finally give you only whether it's a class 0 or 1 or 2. Now, we need this when you're deploying it to understand the order of the classes. So when I print the class name, it's telling the first is the Angular leaf spot, second is the bean rust, and third is the LT category. So there are 3 classes that are available. Okay, now this is about that classes. I can also quickly visualize the different images. So what I'm doing is I'm using Matplotlib to visualize. If you see over here, I'm just setting like a figure size 10:10. I am going to train DS. I am taking 1. That means it will take 1 batch. That's what it's going to do when I say take 1 from the train DS. And I'm taking the images and label. I'm just iterating for 10 images. I'm just telling like I in range 9. So I'm going to iterate for 10 images. I'm creating subplots 3 by 3. So it'll arrange like 3 by 3 images. That's what it's going to do. I am printing the image and I am printing the label on the title. So let me quickly run this. And you can see what are all the different images available in the first batch. That's what I'm doing over here. So it's basically going to print 9 images for me because I have given I in range 9, and I have arranged it 3 by 3 in the subplot. So you can see 3 by 3. It's telling this is a bean rust, this is a bean rust, this is Angular leaf spot, this is a LT image. So this is how my images look like, right? So that's about basically what we have done till now. Is we took some zip files which contains the data. We are putting in a folder structure. We are arranging a folder structure. We are reading that using the Keras read from directory method and creating data set objects for that. This data set object, we are going to feed it into our model. Okay. Now, see, this is a quick way of creating a computer vision model, right? You can build your own CNN architecture. What I'm showing you is a quick way. The reason is I have a lot to cover, but I'll have a separate session in the future on computer vision if you are interested, where I can walk you through the detail. But there are a lot of material available online on that, right? So we can read from there as well. Now what I'm going to do is I'm going to, since I'm using GPUs, I may want to prefetch my data into buffer so that my model training is fast. So what prefetch does is when the first set of batch is training, it will keep it in the cache and serialize it into the GPU. So for that, I'm using prefetching. That's what I'm doing in this line. So I'm setting auto tune. You can also do manual tuning. But for now, I'm just telling auto tune. Auto tune is basically going to understand based on the GPU availability, memory availability, and auto tune for us. And then I'm taking the train and validation data set, because these are the two data set I'm going to use during training, right? So I'm taking the train and caching it and doing a prefetch. In the prefetch also, I'm giving the auto tune, right? So what it's going to do, it's going to take the data, keep it in the memory for me. It all depends on your GPU memory. How much memory you have. You can even set the batch size higher. If your GPU is pretty good in memory, it will pretty much work seamlessly. And I'm telling it, you tune it by yourself, rather me manually tuning it. There's manual tune also an option. So that's what I'm doing here. In this case, the data set is now in the cache, the train and validation data set. Now to train my model, what I'm going to do is I'm going to use an pre-trained model. And the pre-trained model, I'm taking it from TensorFlow Hub. So let me go to TensorFlow Hub. So if you go to tfhub.dev, you can find a lot of pre-trained models over here. There are pre-trained models for text classification tasks. There are pre-trained models for image classification tasks. So if you go to the TensorFlow Hub model, now what I'm going to do is you have the text problem domains and image problem domain. I see like a lot of messages coming in. Now, in case if you have joined late, so what I'm doing over here is I'm covering these steps. I'm first going to train an image classifier model. I'm going to create a Streamlit web application. I'm going to do an automated build script, manual trigger into K8. So in the Kubernetes, we will see the Kubernetes YAML file definition and everything. I'm going to do GitHub integration, and I'm going to do automated CI/CD pipeline. Okay, so all this I'm going to cover. Let's just first go to the training step. Now, in the TF Hub, you will see like text problem domains, image problem domains, and we are going to build an image classifier model, right? Now, in the image problem domain, you have object detection and segmentation pre-trained models, and you have for classification, you have feature vector and classification. These are two categories. Now, a feature vector is basically contains a trained instance of network to get feature vectors. So basically what we are doing is we have a model. This is a pre-trained model, but what we are interested is only the last layer feature vector, because I'm going to add my own classification head for my own custom data set, and I'm going to transfer learn it. If you want to just use the existing model, you can go to classification and take the model and load it. So let me click on feature vector. In the feature vector, if you click, you will find a lot of models over here. You will find Inception v3, you will find MobileNet, ResNet. There are a lot of models that you can reuse from this particular repository. In our case, I'm going to use a mobile VNet feature vector. So this is what I'm going to use to transfer learn my model, right? And if you come to over here, it will show you a sample code on how you can use it. Okay, and if you want to kind of more do fine tuning, you can set this trainable equal to true, and you can go and fine tune all the layers. When you're fine tuning it, basically you are kind of adjusting the weight for all the layers. When I am doing transfer learning, I will just take the existing model, take the existing features, existing weights that are generated, and attach my own classification head to it. That's the only difference. So this is how you use TensorFlow, this TensorFlow Hub. Now what I'm doing is, if you see mine, I am getting this feature extractor layer over here, which is nothing but this one. You can see it over here. This is the feature extractor layer, and I am assigning it to a variable. Okay, that is the feature extractor variable. And then I am using the up.keras layer feature extractor. I'm passing my input shape as 222, where the image height and width is something I have configured on the top. If you click here, 224, 225, and there are three channels. So rather they are given in one line, I'm just breaking it down. Okay, so that's what I've done over here. I have the feature extractor layer. I am training. I don't want to train it. I am just going to attach a classification head. Now, which option will you use when? Now, in my case, I'm telling don't fine tune the model. Just use the classification. I'm just going to include a classification head. Now, take for example, right? You have a pre-trained model, and the pre-trained model was used in 1,000 different categories. And your business problem is to detect the semiconductor type used in a PCB board, printed circuit board in the electronics industry. Now, if you see in this case, your data is completely different than the 1,000 categories of the pre-trained model. So in this case, and you assume you have a lot of data. So basically you will feel like, okay, I want to, rather using the model, I want to use the architecture only, and I want to go and do a complete training of the model, or I want to go to a particular layer, and then I want to basically tune from there. So that's when you will use true. In my case, basically in the 1,000 categories, leaf is a category. And what I'm doing is I'm going and fine tuning the leaf into different infection types or different disease type, right? Now, take for example, I have a dog and cat classifier, but my pre-trained model knows can identify dog and can identify cat. But in this case, I want to go one level down and see whether what dog breed it is. Is it a dog breed? Is it a B dog breed? At that time, I can just set it false and then use the feature vector that are coming in and just create a classification based on my data. And that's what I'm doing over here. So I will show you how to do that. So I'm setting false. I don't want to fine tune it. I'm just going to use the feature vector that is available. That's what it means. Now, the very first thing you do in the image classifier is you kind of normalize the images or rescale the images. Okay, so typically what you do, you take the image pixel and divide by 255. This just for your algorithm to work faster, right? Rather than working in the range of 0 to 255 pixel range, 0 to 1 ranges, so that your optimization algorithm works faster, right? So in this case, what I'm doing is, rather than creating my own function to scale it by divide by 125, I have divide by 255. What I'm doing is I'm using like TF Keras layers. They're still experimental, so they will change it to directly pre-processing. And then I'm using rescaling method. I'm telling rescaling 1 divided by 255. How is this different from just using your own function? In TensorFlow 2.4, right, what they have done is they have attached the pre-processing as part of your model development itself, or as part of your graph development itself. If you're using 2.1, 2.2, 2.3, then you just take it out, create a function, and then use that function separately. You deploy the function as well. That's what you will do. But since I'm using 2.4, I'm going to put it as part of my model itself. This simplifies the process of model deployment, as everything comes part of the TensorFlow graph itself. Okay. So here I have the normalization layer. I'm going to run this. What it will do is the input images, it's going to divide the pixels by 255. I'm setting the random seed, which is which matches my in this case my what I have given in my data set directory as well, just to make sure my experiments are reproducible. Okay. Now, next I'm creating the model architecture. Now this is where here I'm going to use the model from the pre-trained Keras sub layer. But you can also bring your own convolution neural network model. That is the only reason I'm doing this, is to do it pretty quickly so that I can move on to the deployment part of it. Now, coming to your own model, you can use either your custom layer, you can use any kind of auto ML tool, or you can use some kind of tuner that will find the right architecture, right framework and everything, right? So here what I'm doing is, in the Keras sequential layer, I am first putting the normalization layer. So any data that comes in, divide by 255. And then I'm putting my feature extractor layer. The feature extractor layer is nothing but the mobile VNet model that we imported on the top. And finally, I am just adding a dense layer. They are telling 3 because there are 3 classes. There is 2 disease classes, Angular Spot and BNest. And there is 1 class which is basically LT class, and I'm using a softmax function. I'm creating a dropout over here, just that it does not overfit. Okay, now it can be anything. You can add even more layers to it and everything. It's up to your customer to make the model better. But I'm just using a simple architecture here. Okay, and once I have it, I am going to compile my model. Here I'm using the Atom optimizer, and I'm using a loss function sparse categorical cross entropy. Now there's a categorical cross entropy, there's a sparse categorical cross entropy. Now the only reason I'm using sparse categorical is I didn't one-not encode my target. If I'm one-not encoding my target, then use categorical cross entropy. Here my target is as it is, so I'm just using sparse categorical cross entropy. I'm giving metrics as accuracy. Now again, the metrics will change in real world if you have very imbalanced classes and all, but let's go with that now. And I'm going to start training my model. So now what I'm doing is I have my model architecture. I have my model, basically a loss function and metrics. I'm calling a model.fit method. I'm telling train it for 20 epochs. And this is my validation data set. And this is my train data set. That's what I'm passing. So it's going to use my data set for training. And after every epoch, it's going to go and run against my validation data set and go and validate the model, and it's going to print the accuracy, the train accuracy, as well as the validation accuracy. That's what it's going to print. Okay, so this training will be very fast. So you can see, like, as the model progresses, you can see how the accuracy is. The train accuracy is 0.42, the validation accuracy is 0.68, and in each epoch it might get better. Now you can run it for higher epochs, or you can run it for lower epochs depending on the accuracy you want. I just going to run for 20 epochs and see how my model performs. And again, as I said, right, the idea of this particular session is not to develop the best model, but to show you the end-to-end process, right? So there are a lot of steps still involved after the model development. So we will see how to do each of it. Now, it's training, it's around 30 epochs. You can see, like, after 14 epochs, the train accuracy is 88 and validation accuracy is 90. You can also put an early stopping. So if you are training for 50 epochs, and you can put an early stopping, if the validation accuracy does not improve, just do a stop, right? In this case, if you see, the validation accuracy is pretty constant, and after some time it's increasing. Now it's 92% is the validation accuracy. The test train accuracy is 90. So the 20 epochs is complete. You can basically see my accuracy is 89 train accuracy, and the validation accuracy is 93. Now this is just the training part of it. Let's see whether this accuracy holds true during our test data set inference. This is a data set that the model has not seen at all, right? Only the validation data set and the train data set the model has seen and use it for validation. Now before that, let me go and print the model summary, which will give the model architecture. And you can see that's a rescaling layer, which is inbuilt to the model now. Now you don't have to separately create the rescaling layer. It is inbuilt by your model. So yeah, if I deploy this graph object, then my entire pre-processing is also deployed. And you can do a lot of pre-processing. When it comes to just go check Keras pre-processing, you can do a lot of pre-processing. If you're using structured data, you can use your one-not encoding, you can use your standardization, any logic within the graph itself now with TensorFlow 2.4. Now, what I'm going to do is quickly go and plot my validation accuracy and loss for thing. So you can see this is the accuracy, this is how the accuracy looks like. Basically, my validation accuracy is better than train accuracy. There is no overfitting or under, but we don't know until we go and evaluate with my test data set. So I'm going to go and evaluate my test data set and see if my validation accuracy hold true or the train accuracy. Now, if you see over here, it is 89, which is close to my train accuracy. My train accuracy was around 89, and it is close to that, but my validation accuracy was 93, but it's still less. I would still not call it overfitting, but you can go and run for multiple data set, because see, the sample in test data set is very less. There are only 133 images, so you may not get a right function unless you have a lot of data to tell your hypothesis, okay, it's overfitting. It's a decent enough model. What I'm going to do is I'm going to go and visualize the output of my model with the actual label and the predicted label. That's what next I'm doing. So here I am again setting my figure size as 10:10. I am taking one batch of data from my test data set now. I am taking the first 9 images. I am creating a subplot. I am arranging it to 3x3 layout, right? I am calling my Keras pre-processing image to array function. Basically, I am taking the images and I'm converting that image to array. I am just expanding the dimensions over there, and then I'm calling the model.predict method with the image object. So this model.predict is going to take individual images now, and then it's going to predict, and then I'm going to display it using Matplotlib. I am telling what is the actual label, what is the predicted label, what is the image. So once I run this, I can quickly visualize my output on what is the actual label and what is the predicted label for first 9 images. You can run for more images. So if you see over here, this is the image. The actual label is bean rest, and our model predicted bean rest. Here the actual label is angular spot. The model predicted angular spot. Similarly, let me quickly run it down and see. In this case, the actual label is bean rest, but my model predicted angular leaf spot. So this classification was not right? So that's why we don't have a 100% accurate model, right? So these are the model will generate some errors, but others seems to be fine. Only that one image out of 9 had issues, right? But that's fine. Now what you can do is, if you want to go and fine tune further, you can bring your own CNN model. You can get more images. There are a lot of other factors you can do to make it accurate. But what we have got is a 90% accurate model, which is pretty decent for a simple model. We did not build anything. We just used a transfer learning to get the output, right? Now what I'm going to do is I'm going to save this model, right? Because this is what we are going to do and deploy it, and we are going to build a CI/CD pipeline. Okay, so let me save this model. I'm just calling the model object.save method, and I'm saving it to the models directory, and I'm telling the save format is TensorFlow. Now TF is the latest format. You can also save it in H5 format, which is kind of an old format. So now it has saved the model. Let me print the models directory and see what objects are there. So in this, I have a folder called asset. So let me do an ls-elrt. So I have a folder called assets and folder called variables, and I have a save model.pb, which is nothing but the graph object that I have, and I have keras metadata.pb, which tells me the overall keras metadata, including the pre-processing function. Okay, so this is how my models directory is. Let me just quickly verify it. Now, when you are doing an inference, you want to do an inference on a single image, right? What we did earlier was a batch of images. So how I can do on a single image, right? So now I have the model saved. I am going to load this model and verify it. So let me quickly call the tf keras models.load model method. I will load the models directory. I am creating a new object called model_loaded. Okay. And then let me print the model_loaded.summary. So this will give me the summary object. Now the architecture is same, right? Because I'm just loading the model now. Now next what I'm going to do is I'm going to go and predict for a single image, right? So I'm just importing the pillow package to for my image processing, and sklearn image for the transformation of images. Okay. Now what I'm going to do is I am basically here calling my image. This is a function I have written. The input to the function is an file name. In the file name, I'm just opening the image. I am creating an array of the image object. I am just resizing from the SK image. I'm using the transform function, and I'm giving 224, 224, 3. That is my image height and width that I have given on the top. Okay, I'm resizing the image, and then I'm just expanding the dimensions. The reason is now if you see, it's like 3 dimensions, 224, 224, 3. But it also requires batch as a dimension. So that's why I'm doing a expand dimensions, because it will create 1, 224, 224, unless I don't give an explicit what is the batch size. So that like model expects like batch, image height, image width, the channels, right? So I'm just expanding the dimension, and I am just returning the final image. So this is just a function, right? Now what I'm doing is I'm in the model.loaded, I'm calling the predict method, and I am calling this process function that I have defined on the top and passing an image over here. And I am printing the label. This classes is nothing but, I told you on the top, what I'm doing is when I'm training the model, I am taking the class object. If you see on the top, when I created the data set, I have showed a class object. So this is required during deployment, because what my model will give me is just 0, 1, or 2, or some kind of probability score. We will do an argmax to get the maximum probability, and we will use it, right? So in this case, if you come down, I'm using the classes object. I am calling the predicted label. If you see over here, right? Let me run this and show you. So it's going to print the classes healthy, but the predicted label object is just going to be an array. It's telling, okay, the class 0 is 0.001, the class 2 is 0.04, the class 3 is 95. So this is the maximum probability. So the class is basically highly probable, and then this is the class we want to pick. So that's why we are using the argmax function. It will give the maximum predictability, and it from the classes array that we had created on the top, we are getting what classes is. So this is a LT class leaf, and if you see, that's what we had given. It's a LT class leaf. So this is how finally what we did is we took an data set, we trained a model, right? And then what we are doing is we are basically predicting using a single image as well as batch of images. Now this is the model that we are going to deploy. Okay, now I'm zipping this models file, a model.zip, so that I can move into my GitHub repo, and then I can keep the model. I can create my own I can create my serving script and then serve it. I can also use TF serving. I can use a lot of other methods to deploy it, right? So I'm not going to zip it because I've already done it. It takes time to download and upload. And then I'm just printing the TF version. I'm using the latest version 2.5.0. Just always remember, when you're deploying, make sure the TF version, when you're creating the container, in our case, we are going to create a container, it matches the version of year. The reason is the TensorFlow APIs have been pretty drastically changing starting from 1.x. So every time you install a new version, you can see that the previous version fails. And you just want to make sure the version matches so that your deployment is working, right? So I'm just printing the version over here. So now I have the model, I have the model object. So what I have done is, if you go into my GitHub repo, all this particular model and serving script, I have not updated this training script. I will update that. But if you go into the repositories in my GitHub repo, my GitHub repo is github-srivatsan88. Okay. And then you basically go to the repositories. I have created a new repository called continuous model deploy. Okay. This is where all the code that I am using today is over there. Here, what I'm doing is, in the models directory, I have already loaded this Keras metadata and saved model and the assets and variables folder. In the variables folder, you will have all the variables that are there. And basically, if you come over here, I have other code that we will use as part of today's code, which is a Streamlit web application to create a Kubernetes YAML file is over here. I will explain that in detail, but this is the model training part. So if you see over here, what we have done is we have completed the training image classifier. From now, we will go to the next step. So this is my repo that I'm going to use. Let me do one thing. Let me see. Now you can deploy it anywhere. You can have your own Kubernetes cluster. You can run it on a serverless environment. It can be AWS Lambda, or it can be your AWS Fargate, or it can be Google Cloud, Cloud Run, or App Engine, or it can be anything, right? Or it can be your on-premise. It can be a combination of Jenkins, your own physical virtual infrastructure. I'm going to use the Google Cloud Kubernetes engine. See, the process is still the same. The only reason I'm using Google Cloud is I have access to Google Cloud Kubernetes engine, but you can use anything, anywhere. The process is still the same. The only script that will change is the cloud build.yaml that I'm going to use, because AWS has its own specification, Azure has its own specification, Jenkins has its own Jenkins.yaml file, right? So that will change. So let me go to the Google Cloud console. Right, and this is how the Google Cloud console looks like. See, if you are new to Google Cloud, you can sign in for Google Cloud and get a $300 credit. Most of the tutorial that I'm showing, it will not get charged much. It gets charged hardly few cents overall. But if you get the $300 credit, it's going to be completely free for you to test it, and you can learn Google Cloud as well. And I have a course on Google Cloud AI as well, which you can go and check. Okay. Now what I'm going to do is, once I have Google Cloud, I will basically go and activate Cloud Shell. You can see the link on the top. There is something called Activate Cloud Shell. Once I click on that, it's going to open a kind of an Unix command prompt on the bottom. Okay. Now, once that is done, what I can basically do is I can open this particular thing in a new window. Okay, so if you go over here, click on the top, it will open that in a new window. So I'm getting a complete Cloud Shell. Okay, the Cloud Shell, my project is already set. Let me go to LS, and what I'm going to do is I'm going to my GitHub repo. I'm going to clone this particular repo. Okay, see, this is a live session, and in case if something fails, I will tell you the process. I did not get a lot of time to test this end-to-end process because I scheduled this session only yesterday, but I hope it will work, and it should work. But if not, I will explain the process. Okay, so what I'm doing is I'm doing a Git clone, and then I am just copy pasting. I just copied my clone repo directly, and then let me kind of clone the objects. So once the objects are cloned, let me do an ls, and you can see the continuous model deploy directory is there. Okay, now Google Cloud also provides an editor for you. So what I am going to do is I'm going to open the editor. When I click on editor, you will get an editor over here. In this editor, I'm going to say file, open workspace, and I am going to click on the latest directory that I copied. Okay, so I'm going to do open, right? Now, before we get there, before I explain the code of the deployment and Streamlit web application, we are going to use Google Kubernetes engine. Let me kind of close this. We are going to use Google Kubernetes engine, right? So Google Kubernetes engine, now there are multiple things that comes into play. Let me go to the presentation. This is what we are going to do first. Okay. Now, the source code that we are done is not in GitHub. It's in local now, right? Now, the GitHub integration will be the next step that I will do. But here it's in local. I just cloned the repo locally. I'm going to create a cloud build. Now, cloud build is nothing but a packaging software. It's like a Jenkins for you on Google Cloud Platform, right? And then I'm going to create a container. So what I'm doing is I'm creating a Docker container, and I'm going to put it on a container registry. And I am also parallelly going to read the Kubernetes manifest file and then do a cloud build and deploy it on Kubernetes engine. So basically this will be deployed as a pod in the Kubernetes engine. Now for that, first I need a Kubernetes cluster up and running, right? So for that, what I'm going to do is I'm going to create a Kubernetes cluster. That's what I'm going to do. Now to create a Kubernetes cluster, if I go to my Google Cloud platform over here, I can type GKE, which is nothing but Google Kubernetes Engine. As I said, it can be your own Kubernetes engine or it can be any cloud. The Kubernetes is open source software. The underlying principles are same. The principles does not change, right? The only thing is the environment changes. I'm still going to use the same kubectl command to deploy. Now to create a cluster, I can go online and just do a create and create a cluster. But for our case, what I'm going to do is I'm going to do it in a command prompt. So to do that in the command prompt, now you can also automate the Kubernetes cluster creation. Now, in a typical enterprise, you don't run Kubernetes per project. You share a Kubernetes environment. So you will always have a Kubernetes up and running and you can deploy it. But in case if you want to create your own Kubernetes automated, you can use Terraform or any other script to do that. Okay. Or you can even use a shell script and put this command. You can schedule it by Airflow or any other scheduling tool. Okay, now here what I'm doing is I'm telling gcloud container clusters. So I'm telling create a cluster, container cluster, which is nothing but a Kubernetes cluster. I'm telling the name of the cluster as project-cube. What zone I want. This is the zone in GCP. I'm telling create in US West 1B. What is the machine type I want? Do I want a GPU machine or do I want a normal machine? So that's what I'm telling. I'm telling like create a standard machine, how many nodes I want. I'm telling just give me one node. But depending on your scale of the project, you can create 10 nodes, 20 nodes. And I'm just giving my service account. The service account is nothing but where I configured some permissions, right? Now, as a MLOps engineer or as a developer or as a machine learning engineer, this work is taken care by your administration, right? So you don't have to worry much about it. But if just for in the sake, if you want to try it out on Google Cloud, you create your own service account and try it out, or you can ignore the service account completely. The only thing is the cluster does not have any security over there, right? So let me run this. I'm just going to say authorize, and it's going to start creating the cluster. While the cluster is getting created, let me go to the code now. Now, I told you this is the model directory that we have, where I have copied all the model that we trained some time back, right? It has the asserts, variables, keras metadata. It has like a save model.pb, all these files. And then I have a Docker file over here that will create a container for me. I have a requirement.txt file that tells me what are all the software I need. And this is where basically it's good to always mention equal to 2.5.0. right? Because what TensorFlow version I'm using. Now, because I'm using the latest version, I have not given anything. But if you want, you can give your own version. I am telling Streamlit because I'm going to deploy this as a Streamlit web application. I'm using Pillow for inference, NumPy for getting my object and basically converting it to a format, and request to within my Streamlit application. Okay, these are the packages I'm using. Now, in the Docker file, what I'm telling is use a Python environment. I am using the Python 3.7 Slim environment. Now, remember one thing, right? The Docker container, make sure your Docker container is lean. Now you can use full Python version and blow up your container size. But if you want faster deployment, you keep your container size lean. It's always good to have the model also outside the container. You can mount your volume models in external volume so that the container deployment is faster and it just read the volume. But here I'm going to copy the model inside my container, and I'm just running an apt-get update, which will make sure my by default OS gets as all the softwares, right? Latest softwares. I am creating an environment variable app_home, and then I am creating /app directory. So this is where all my external data, my models, my Streamlit web application file, everything will get loaded. Wait a minute. I am having just a minute. I think I'm having an issue with the internet. Let me, yeah. Just give me a minute. I'm coming back online. So while this back online, you can see the project, the Kubernetes cluster is getting created over here. It is still in the process. Now let me go and open my editor. And then, yeah, now we are back. So now, so what I was saying, what I'm going to do is I'm going to copy all my web application into this. I'm telling like basically just print the directory structure over here. What it's going to do is whatever is in the directory structure. So in the dot copy, right, what it is going to do is anything that's in my directory over here, the current directory where I'm running the Docker container from, it's going to copy everything into the /app directory. While we are seeing that, you can see the Kubernetes cluster is created on the bottom and it's in running status. If you go to the console and you refresh it, you will see the Kubernetes cluster is created. So the cluster is up and running. Now, I'm copying all of this into my Docker container. I am just printing my current directory just for the sake of traceability and making sure that everything is fine. All my models and everything is loaded. I'm doing a pip install of requirement.txt. Requirement.txt is all the softwares that are required in my Docker container. I'm just installing what softwares are required. And finally, I'm telling run the Streamlit application. Now, before getting that, let's go to the Streamlit application. So this is my image web app.py. This is my Streamlit application. What it basically does is create your TensorFlow model as a Streamlit web application so that I can just pass the image URL and I can generate my prediction. Here, I am importing some packages. I'm importing Streamlit, pill, request, TensorFlow, because mine is a TensorFlow object. I'm just setting some options over here and setting the title of the web page. My title of the web page is Bean Image Classifier. My text in the title, right? Because I'm giving a text box where you can enter a image URL. Okay, so that's what I'm doing over here. And then I am basically getting my input text. So basically what I'm doing in text input, I am asking for a URL. Here by default, I have given a default URL of an image. This image is from internet. See, this image is not part of the data set. I'm taking a completely new image and trying to predict it. And that's how your real world will be. It will not be always from the distribution will not be the same. Your model should generalize to real world images as well. Right. So I'm just taking one image from the internet. I am just giving it over here. I'm getting the path object, right? The text input is nothing but a Streamlit in a text object, which will take an input value. And that value is a image URL. And this is a default one, but I can override it once my Streamlit application is up. And what I'm going to do is I'm going to basically set the path over here. Check the path. If it is path is not null, then I am getting the content from the path. So what it is going to do, it's going to get the path URL and get the bytes of the image, right? So now we have a URL, but for TensorFlow, you need the byte array object, right? So that's what it's going to do over here. I'm just writing the predicted classes, and then I am just classifying. Spinner is nothing but it will just wait till the classification happen. Sometimes if the classification is pretty high, if it's in milliseconds, it's not really going to show you any kind of cycle rotating or something like that, right? So I'm just using a spinner object in the Streamlit. I am calling the argmax, the same thing that we are using the training, right? And what I'm doing is I'm telling basically model.predict of this particular object. Model.predict of decode image. Now decode image is nothing but a function over here. Okay, before going there, I think I skipped this important step. The very first thing I am doing is once my model is loaded, just a minute. I think I skipped some of the step. So in the load model, I'm loading the model, the Keras model load model, which nothing but the app model directory. Now, if you see in the Docker file, I'm slashing my apps directory, and all I'm copying over into the app directory. So the app model will contain all my models. So I'm just loading the model, which is similar to the training file that you saw, right? And I am returning the model object, and I'm calling the load model, which will load the model when the application starts. Remember one thing, right? You don't want to load model for every inference. Okay, so what I'm doing, I'm telling cache this. So the load model will be cached. So when the Streamlit application starts, it's going to load the model and keep it in the cache. And after that, only the prediction method is going to get called. It's not going to call the load model again, right? Loading model will take time, and you don't want to do that again. And then I'm giving the classes list, which is same as the training classes list, right? And the decode image, what I'm doing is I'm just taking the input image, converting into 224, and my channels are 3, which is the default image size for our model. And then I'm just expanding the dimension so that I have a batch dimension to it. That's what I'm doing. Now, coming back to the predict function, I'm calling the decode image a function that is on the top, which will take and resize the image, pass the content, which is nothing but the byte array of the image, and call the predict method. It will get the maximum argument, which is the most probability the model thinks it is. And then it is basically going to create and get the classes. Basically, it's going to get the index of the class, whether it's a LT, AngularLif, or BeanRust. If I don't have it, it will just give me a probability score, which does not make any sense to the end user, right? You want the actual class labels, and that's what it is doing over here, right? And finally, what I'm doing is I am opening the image also and then displaying it in a web application so that you can see what image it is. So that's what this Streamlit web application it's over here. Now let me go to the Docker file. In the Docker file, now I know it's too many things because the Docker and Kubernetes is nothing about configuration. You need to have a Docker file to create your container. You need to have the Kubernetes YAML file to tell the specification how you want to deploy it in Kubernetes. That's what you're doing, right? Now, to run a Streamlit application, I call the Streamlit run method. Here I'm setting something called enable CORS, which is nothing but class reference sites. Set it to false because sometimes the images and all it basically considers as some sites blocks it. So by setting this, it will make sure it shows it, but still sometimes you may see that issue. But if you are running on a trusted environment, you can just remove this one. And I'm calling my image webapp.py, which I have given over here, which is nothing but my Streamlit web application. So what this container is going to do is when the container starts, it's going to run the Python 3.7, get the Python 3.7 image from the Docker Hub. It's going to do an apt-get update. It's going to copy all my local files, models, and everything into app directory. It's going to just list the directory structure. It's going to install all the requirements for my model, TensorFlow, and all the packages that are required. And then it's going to finally basically take this and call the Streamlit web application, start the web application for us to use, right? And that's what the Docker file does. Now I have a Docker file. Next, I need the Kubernetes specification because I'm going to take this Docker. This Docker can be deployed anywhere. This Docker can be deployed on Azure. This can be deployed on Azure Kubernetes service. This Docker can be deployed on Cloud Run serverless infrastructure, Lambda, Fargate, any AWS environment, anywhere you can deploy it, right? This specification is not going to change anywhere. Docker specification is Docker specification irrespective of your environment. Kubernetes also is the same way, right? And that's the advantage of Kubernetes because you can bring in Docker and Kubernetes because you can bring in a cloud independent architecture. You can deploy on-prem, you can deploy on cloud. Now, in the Kubernetes, I have two files. One is a deployment file and service file. Now, deployment file tells me about details about the deployment. It tells me basically what is the pod I want to create, what are the structure I want to create and everything, right? How many replicas I want. So this is the deployment.yaml file. It's a pretty simple deployment. The deployment.yaml file can be very complex. If you want to do champion challenger deployment, if you want to do canary deployment, all of this has to come in the deployment.yaml and the service.yaml file. Okay, now here simply I'm telling the name of my particular deployment. It's a kind deployment, which is nothing but the Kubernetes is telling it's a deployment type. The name I have given as image class. I'm telling 2 replicas. Now the best thing about Kubernetes is scalability. You may get 1 request per second, you may get 1,000 requests per second, or 1,000,000 requests per second. Now, how do you scale it? Based on the replicas. You can tell how many instances of my application is required to make it up and running. That's what replicas is. Then I'm giving just a label over here, because I can go and select by label. I can scale it. I can pin it to a particular node. If I want a GPU node, I can pin it to a node. There are a lot of things I can do with the label, right? And I'm giving my container name. So when my Docker file will create a container, I need to tell where the container is. And that's where the cloud build comes into play. But first, I'm giving a container location that when you're building a Kubernetes pod, the container is in this location. Go and take the container, deploy it on Kubernetes. The container port is 8501. I'm just giving over here. The 8501 is the default port that Streamlit runs on. Okay, so this is deployment.yaml. Now, deployment.yaml is nothing but a specification on how many instances of the container you want, what is the name of the container, what is the name of your pod, and where the container is located. The service.yaml is nothing but how you want to connect to the external world. You have a deployment. The deployment is within your Kubernetes infrastructure. You want to expose this deployment to the external world. Anybody in the outside world must access. That's why the service comes into play. So how do you want? You want a load balancer? Yeah, yes. So you want to basically balance your incoming load. There are a lot of options. You can see here the kind is service. And then I'm telling my image classifier is the app, which is nothing but the name I gave over here. Okay. And then I'm telling my target port is 8501, but this port is 80. So I'm just mapping my 8501 port to 80 and my exposing my web application using service. This will give me a URL where I can go and access my web application. Okay, that's what the Kubernetes.yaml file is. I know it's going to be too many things if you're completely new to Docker and Kubernetes. I have a separate video that you can go and check where I have covered hands-on Kubernetes and Docker for your for data scientists and data engineers. I covered all of this, but you can check that. Once you start trying it out yourself and reading the documentation, you will be completely comfortable with Docker and Kubernetes. It's pretty easy. It's only configuration, right? Now, if you want to, the best thing about this is here you can set your see when you have a model version A running, you are deploying a model version B. You don't want to override the model, right? You want to maybe run it in a champion challenger mode. You want to run it in blue grid mode. You want to run it in a canary mode, right? So that's all the setting will go into your deployment.yaml and the services.yaml telling how you want to deploy it. In this case, I'm just going to override it, but those options are there. Okay, now this is my K8s file. This is my Kubernetes YAML file. This is my models directory. I told you the model we built. The Docker file, it will create the Docker image. And this is the file that is going to create a build for you. Okay, now this cloud build.yaml is basically going to take your artifacts, build it, deploy it on create a Docker image and deploy it on Kubernetes. That's what it is doing. Now, this build file is very similar to a Jenkins. If you're doing an on-prem deployment, Jenkins will have its own build capability. How you configure it? This on Google Cloud. The only thing if you go to an external AWS or AKS or on-prem will change is this cloud build file. You need to do to the specification of the environment you are running in. It can be Jenkins, or it can be a combination of Spinnaker, or it can be AWS code build, code pipeline, all these things, right? Now here in the cloud build is nothing but a bunch of steps. Now let me go to the presentation. What is the first step I want to do? I want to create a container registry. I want to create a container and push it to the container registry. That is the first step I want to do. The second step I want to do is I want to read the Kubernetes and create and deploy it on Kubernetes engine. The Kubernetes engine is nothing but what we have created over here. We have created a Kubernetes cluster, project-cube, right? So that's what we have done. So that's what we are doing over here. Now, the first step, what I'm doing is I am calling it, call the Docker builders. Okay, and I'm telling my project, right, whatever I have build-t, it will look for something called an Docker file within that particular directory. But I'm giving dot, which is the correct directory. It is going to look for a Docker file over there, and then it's going to build the Docker file, create a container, container image. In this case, not a container. Container is a runtime. Container image is just nothing but a static version of your container, which has all the dependencies embedded for your package. It's going to create a container and then push it into image webapp.v1. The project ID is nothing but the Google Cloud project ID minus Srivatsan project. And if you see over here in the deployment.yaml file, this is what we have given the container name. So in the cloud build is building that container for us. And this, now we have a container image. We want to push the container image somewhere. We want to push it into an container registry. Docker Hub is a public registry. The AWS has its own registry. I am going to push it into the Google Container Registry. And for that, what I'm doing is I am calling my cloud builders, again, Docker. I am after the build, I am telling push it to the registry. So I'm going to show you the registry and all. Just bear with me. It's going to create the Docker. It's going to keep it in the registry. And then I'm just, see, the reason I have given this is not required, but you can execute any script you want in the cloud build. Here I'm just executing a bash script. I am just doing an echo. I am doing ls-la anything. But if you have a shell script, you can execute it. You can do a lot of things in cloud build. You can say after the container is built, you want to move data, move files, move folders. You can do anything you want. I just give an example here on how to use it. Here I am just running an Unix bash script. So that I can just perform some commands. But this is completely optional for this particular video. Just to show the art of possibility, I'm doing it. Right. Then what I'm doing is I am finally going to deploy it on a Kubernetes engine. And for that, I'm calling a builder called GKE deploy. GKE is Google Kubernetes engine deploy. And I'm telling run. The file name is in the KH directory. That is nothing but the KH directory, the deployment.yaml file and the service.yaml file. Right, and the location is US West 1, and the cluster is project-cube. That's the cluster we created. If you see, this is the cluster project-cube. So basically, what I'm telling in this cloud.build.yaml, read the Docker file, create the Docker image, push the Docker image into the container registry, execute some steps so that I know exactly if I want to debug, I can do the debugging script in the bash, and then move the image. Read the specification deployment.yaml and service.yaml, which is in the KH directory, and then deploy it on the Kubernetes cluster. So now I have created the build script over here. Okay, so that's what I have done. Now I have all of this, right? Now, first thing I'm going to do, let's go back to the container. And first thing I'm doing is I'm just doing a manual trigger. So I have a local source code. I have not integrated GitHub yet, but I want to test it before going there, right? It's going to build a container. It's going to build container registry. So what I can do over here is, let me go to the Cloud Shell. Okay. Now I have all these things I walked through. The cluster is created. Let me go down. I'm sorry. Yeah. Let me clear my screen. So to run this cloud build.yaml, we are going to run only the cloud build.yaml. What you will do is you will do gcloud. Okay, builds is run the cloud for the command to run the build submit. Now build is nothing but when you are creating a Java application, when you are creating an web application, you will create a war file or jar file. That is also possible here. So build is nothing but your build tool. You can relate it to your Jenkins build, it can relate it to your Maven build or those kind of build command. Okay, and this is for your specifically for Google Cloud, which is a managed infrastructure. Okay, now I'm telling gcloud build submit config, and I'm just going to give my wait. I have to move into the directory first. Let me do ls cd continuous model deploy. I moved into the directory where my cloud build.yaml is. I'm doing gcloud builds submit. Cloud build.yaml. Okay, so this is what I'm giving, and let me run this. So it's going to read the cloud build file. It's going to create a Docker registry. It's going to do everything in the steps. The better way to visualize how it runs is, see, currently, if you go to the project cube cluster, there are no workloads, no application running. There are no services running. The applications are nothing but what we gave in deployment.yaml file, and services are nothing but the service.yaml file. Okay, now let me go to the cloud build first, and container registry. There's one more service called container registry where our containers will go, images will go. That is also empty now. Everything is empty now, right? So let me go back here. And what was okay, cloud build. Now let me go to the cloud build. You're going to see what the cloud build does. So you go there, go to the cloud build. Now, if you are using Jenkins, you will go and you will see the console log, which will show you all the steps. That's what Cloud Build does. Now, this is the application that is running build. I will click on this build. And you can see these are the steps. The first step is building the image. The second step is pushing the image, running the bash script. And then it is going to deploy into Kubernetes. It is going to show the summary. Now, if you see over here, you can basically follow everything. It's basically installing your TensorFlow package. I did a ls-alrt to print the console in the Docker file. I am creating like the app home. It's installing TensorFlow. See, all the requirements.txt is installing. Each and every step you can verify here. Suppose your build fails. So what you're going to do in your build fails, you're going to come into this log file and you're going to basically debug your build. Okay, that's what it is. It's going to show you everything. It's going to basically see it just like kind of installed all the package. It's going to the next step. It will build the container registry, push it. We'll see step by step once it is done. This takes around 4 to 5 minutes to run. Okay, so while that is going on, yeah. So while that is going on, what I'm going to do is I'm going to go and give you a summary of what is happening currently. Right, in this process, when we did an automated build, which is a manual trigger, I have not set a GitHub trigger yet. That is the next one that we'll be doing. I have a source code in my local. I am running a cloud build script. The cloud build script is going to create a container image. It is going to push it into the container registry. Then parallelly, it's going to read the Kubernetes manifest file, the deployment.yaml and this file. It's going to run a cloud build. It's going to deploy in Kubernetes. The Kubernetes engine in the deployment.yaml file, I have given where my container is deployed in the container registry. It's going to pull the image and it's going to bring my application up and running. That's what it's going to do. Okay, so far so good. Let's go to the build console. I hope it's so far so good. But again, you can watch this video again. The recording will be there. You can go to my previous MLOps playlist. There are a lot of such information. If you want to master in MLOps, I have a complete, if you go to my GitHub repo over here, if you click on this mastering MLOps over here, click here for MLOps, you can see I have an entire playlist on MLOps where it's on Azure. I have CI/CD on AWS, but AWS MLOps is still in the making. I have a lot on Google Cloud. What is a feature store? All the components of MLOps I'm trying to cover here. There are a lot of introduction, even the basics of MLOps. If you want to understand about MLOps, everything is there. Okay, so let's see like how far it is completed. It's still running. So what it has done, let's go and analyze the log, which step it is. Now see here, it is basically successfully tagged the image. That is the container registry it has done. So if you go over here and if you go to the container registry, let's see if we can find the container image. Okay, it's still not come. I think like it has not still pushed it. It has just tagged it. It has not pushed it. But let's wait for this to complete, and we will see there. Okay, the cloud build is coming. 1 minute. I just went into my Google. So by default, what it will do is it will just create a Google Cloud storage where it will store all the temporary files. That's what it does. I will click here to get my build details. And basically, let's see which part it is. Waiting for deploy object. So it has gone to Kubernetes now. Okay, you can even see the output in the console over here. See, waiting for deploy. It's going to deploy in Kubernetes now. So now I think the container registry is done. So now let's go there. Container registry. Let me go here. Now you can see the container registry. The container is created. The image is available over here with a V1 version, right? The image name is image web app. So the container image is created. Now let's see whether the cloud build is complete. Still waiting to deploy in Kubernetes. It takes around like 4 to 5 minutes, but sometimes it takes longer depending on the bandwidth and a lot of other factors. Yeah, I think the deployment is complete. You can see over here all the steps are complete, successful. In case something fails, you will see a red dot. You can go and come and debug and then make the changes and then again deploy it. Okay. So that's what you're doing over here, right? Now, let me go back and go to my Kubernetes engine because I have deployed it in Kubernetes. So GKE is the old name. Now they call Kubernetes engine only. Well, it was Google Kubernetes. Now let me go to my cluster and see if I have some application running. Now, if you see my deployment is done, it's saying 2 of 2. Why it's saying 2 of 2? Because if you remember my deployment.yaml file, I had basically given the replicas as 2. So it has created 2 replicas. If I given 10, it will create 10 replicas. Now, why you want more replicas? To scale. If your incoming TPS is going to be say 100 TPS, 200 TPS, 300 TPS, you want to scale. You can also do an auto scaling, right? So that's what it is, 2 replicas. And how these replicas could be answered, that's why other load balancer type. By default, it's going to do round robin, but you can also run your own custom load balancer as well. Okay. Now I have my application deployed, saying okay. Now services is the second one that we created, service.yaml. It's going to expose my application to the external world. So if you see services up and running, you have an endpoint here. This is the endpoint where our application is deployed. And you remember we configured 8501 port to 80. So now it's running in 80 port. Now let's see if our application is deployed properly. So I'm just going to click on this and open the application. If it's deployed, you are going to stream our Streamlit web application. So see, if you see here, we have the bean image classifier, whatever the Streamlit web app I have created. I have the predicted class Angular leaf spot, which is by the default image I had given over there, right? Now I can also give my own custom image. Let me do that. I will go here and go to Google. Okay. And then I will basically say like bean leaf LT. Let me see if I'm able to find some image. I have not tried this, so bear with me. Okay, let me try to give this image. See, sometimes this image has copyright, so I cannot give it because it will not allow me to collect. Yeah, this looks like it will work, but let me try it out. Sorry. Copy image address, and then see, the real world image will not be from your training, test, or distributions. It can be anything, right? Say you create an app, anybody can load an image. I hope this works. Okay, it says LT class, but the image is not showing. And the reason is basically sometimes this cross-reference site, Google Cloud blocks it. Okay, let me do it again and try it out. Otherwise, like you got the idea, right? Yeah, now it's working. So it's crazy, like sometimes the cross-reference site is blocked, but you can see now the LT image is over here and the class is LT. So I just taken an external image which was not part of my train, test, or distribution status, right? Just to normally see how well our model generalizes to it, right? So that's this one. Now the next step, right? Now we have done a manual deploy. Let me go here. Now I have this one, right? Let me go and delete this two, and let's set up a continuous deploy build. So I'm going to go and delete the services and I'm just going to keep my cluster, and I'm going to delete the deployment. Let's now do an automated build. Okay, now to do the automated build, what we are going to do now is integrate with GitHub. Okay, so it's getting deleted. Let's see, refresh. Yeah, so it's terminating the pods. Now let's go to the third slide and the final slide. I think we are nearing the end of the session. Now this is what we are going to do. We are going to do a continuous ML deployment. What is this continuous ML deployment? So now your GitHub is there. typically what happens, like as a data scientist, you will be writing the code and you will be checking into GitHub. And whenever the code goes to a particular branch, you want to trigger automated build and deploy it in your local environment and test it, right? You want to make sure the new check-in that you did does not fail. Or when you're moving to production, if particular set of your artifacts move from your dev branch to QA branch to production branch, on each branch you want to automatically build build the code and deploy it on your Kubernetes, and that's what it happens. So it can be any source code. Here I am showing GitHub. It can be your Git, or it can be any source control Bitbucket that you use internally. It's going to trigger as soon as a source code change. It's going to trigger a build, and then it's going to do all the steps that are there in the cloud build. It's going to create a container image. It's going to create the Kubernetes manifest, which is in GitHub, and it's going to do a cloud build, and it's going to put it in the Kubernetes engine, but it's going to put it in the Google Cloud Kubernetes engine. So we are going to integrate your Google Cloud with GitHub. That's what we are going to do. So let me go to my GitHub. Okay. The repository, as I told you, is nothing but the continuous model deploy. And this is how whatever I showed you on the console in the local, everything is over here, right? That's what we are going to do. Now, let me go to the marketplace. You can see the marketplace tag on the top. In this marketplace, I'm going to search for Google Cloud Build. Okay, and I'm going to select Google Cloud Build. Now in the Google Cloud Build, I'm going to set up a plan. In this plan, what I'm going to do is set up Google Cloud Build. Okay, well, it charges only after you do some thousands of build. It's free. It will ask for my password. So I'm just now integrating my Google Cloud and this one. So I have to give permissions to it. So by default, it's showing a repo, but let me go here, only selected repos. In this, I can do it for all the repo. Any repo, anything changes, do the build, but I don't want to do that. I just want to go and select my repo that is continuous model deploy. Only this repo when there's a change. Now understand, this repo can be anything. It can be a particular tag. It can be a particular branch as well, not the main branch. I will show you how to do that, right? Because what will happen, you will have one repo, you will have a main branch, you will have a development branch, you may have a production branch, or you will have merge the development branch into main branch for production, right? There are a lot of things depending on how you are structuring your GitHub repo, it will change. So I'm telling continuous model deploy. I am doing save. Once I save, it will take me to the Google Cloud console. Okay, so it will ask me, I will select my Google Cloud username, and it's going to take me to the Google Cloud. Okay, now I'm telling like this is my project. Yes, I have two projects it has taken because one project I configured old. I have said done, and now it's back here. Now my Google Cloud is set up. So again, you can go to marketplace to check whether if everything is fine, and you can search for Google Cloud Build. And if you go over here, it's telling edit your plan, not set up your plan. That means that is set up, right? That's what it says. So my plan is already set up. I can go and cancel my plan anytime. Now let me go back to my Google Cloud window. And here what I'm doing, I'm still, now if you see over here, whatever containers were there are deleted from my GKE. Okay. And now I'm going to go to Cloud Build again. But this time I'm not doing a manual build. I will edit something on my GitHub and automatically the build will get generated. So I'm going to my Cloud Build over here, and then go to your dashboard, right? Now you don't see anything in the dashboard. By default, sometimes it will take it, sometimes it may not. In this case, it has not taken it, and that is good because we can set up our own trigger, right? So there are no triggers. So now I go to my dashboard, I will set up my build trigger. In the setup my build trigger, what I'm going to do is basically I'm going to give a name. I'm going to tell, okay, what is this, like web CV, computer vision web app. Okay, you can give a description, tags. The tags is where like you just give some metadata to search for it. Now, how do you want the event to be? The event can be either push to a branch. That means you can push to a main branch or something like that, or you can create a tag in GitHub and push to a tag. You can also do pull request, that is GitHub app if you have, or you can also do a manual invocation. So you go and manually run it, which we don't want to do. We want to do a push to a branch. Now you can have a webhook event. Whenever there is an event in the webhook, you can trigger it, or you can put a message in the PubSub. PubSub is nothing but similar to your Kafka, which is Google managed PubSub. Okay. So it can be PubSub, it can be any of the option, but I want to do it when I push to a branch. And the repository, I'm going to select the continuous model deploy that we configured. Once you connect your GitHub and this one, you will see that in the dropdown. In the branch, I can give a main branch, I can give a dev branch, I can give any branches that you have. You want to deploy in production, you can give a production branch. Anything that you have, you can create multiple triggers, one for each branch. So that's how you move your code from development to QA to production. Okay, I can even give regex of the branch information. Now the cloud build.yaml file, by default it will look for the name. You can do an auto detect, or you can manually configure the cloud build and Docker file, but I'm giving auto detector. It's going to go and scan my GitHub repo and automatically detect it, and my repository is something which I have configured, right? So let me go and create this build. Now once I created the build, now also it does not run. If you see over here, the trigger is created. Okay, push to branch enabled. It says enabled. I can run it manually, but I'm not going to do that, right? I want to change my GitHub repo, and then you can see there are no builds currently, right? I have just created a trigger now, and that's what I've done. If you see this Excel, I have created a trigger, but the trigger has not got activated yet. Now, how to activate the trigger is basically there's nothing running. You go to your repo again. Basically, I'm going to go to my repo. Okay, and I'm going to the repository that I configured, continuous model deploy, and then I'm going to just go and edit something in the file, right? The simplest thing to edit is readme file. So what I'm going to do is, now you can use your git command to edit or anything to edit. I'm just going to go and click the edit icon here in the GitHub itself, and I am going to say, okay, updated to demo in AI engineering channel. Okay, now once I update it and do a commit, the trigger will get enabled. So if you see over here, let me refresh it. Nothing has happened now. So it will wait for it to listen to the commits. Okay, so let me go here and let me do a commit changes. And the changes is committed. Let me go to my dashboard. Ideally, it should work. Yeah. Now you see the build has started. So as soon as I commit my GitHub, or as soon as I check into my GitHub repository, or to a particular branch or a particular tag, right? It can be a production branch or something like that. Your automated continuous deployment pipeline is integrated. And this is where you have a continuous integration where you are integrating your clusters and everything. And second, you have a continuous deployment pipeline. The continuous deployment pipeline, you can go over here, you can get the commit details and everything, or you can go to the build history. If you go over here, again, you will get the same build history that we got earlier. So it's starting building, it's reading the same specification. It's going to start deploy this particular code. It will take 4 to 5 minutes, but this is the overall summary, right? So let's quickly see what we did in this session. We trained an image classifier model. We took the weights of the image classifier model or the model final learning. We created a Streamlit web application. We created a build script, that is the cloud build.yaml. We created manual trigger, and then we deployed in K8. Then we created the GitHub integration. And now we have a completely automated CI/CD pipeline. On each deployment, it will take and deploy into cloud build. That's what it is going to do. Okay, so this is the end-to-end. I will allow this to run for some time, and I'll start taking the questions now. I know like there was too much information to be covered, and I hope many found it useful. So let me go to the questions. Let me scroll through the questions from the top. Okay. How to set up good test? So that's a question from Stephen Fernandez. How to set up good test cases for deep learning and machine learning code. Okay. Now here it is, right? See, your test cases are nothing going to be basically you will have a sample set of images or sample set of different distribution of data that you have. And within your build itself, you can basically configure an PyTest or something like that, where you go and validate the test cases. And if the test cases fails, it's going to basically fail the entire build. You're not going to proceed with the build, because you don't want to deploy something where your model is not replicated in the production environment well, right? So that's what you do. Now, how to write good test cases, maybe I'll cover it in a separate session, because there are a lot of things to cover on that. Okay. So next question is, can we use the same CI/CD Kubernetes pipeline for deep learning training as well as using distributed training, where each container is a node? Yes, you can do, but this pipeline might not be ideal for that. What you can do is you can create a container. If you want to do distributed training, then I recommend using some kind of orchestrator, right? Kubeflow is the orchestrator. Okay, so you can use Kubeflow, or you can use some other custom orchestrator that you have, or you can write your own. What you can do is you can create multiple containers. You can create a Kubernetes deployment YAML, which ties all the container as a distributed training. This one is mostly for deployment, but for training also you can do using Kubeflow. Kubeflow is the ideal environment to do that. Okay. So let me see the next question. In the entire deployment, can you show some good examples? In the entire deployment framework, can you show some good examples and best use secrets and environment variables? Should we consider H? So see here, the secrets in K8s and everything are more like at the admin side. But if you want to do some parameters that you want to read from your configuration properties, in the cloudbuild.yaml, you can set that. See, one of the parameter, if you see in my code that I have set, is the project ID. I have not hard-coded the project name in my cloudbuild.yaml. So you can similarly set your own parameters, environment variables that you can read within the cloudbuild.yaml file. Okay. So I see the one thing is right. This is not to like cover everything, because once I start covering everything, this will go for like an. I can even run this sessions for an entire week. There's too much information in this. Just wanted to get you started where you can go and explore more. Okay, but yes, whatever you're asking can be done. The next question is, when building these, how to ensure to consider all the installation aspect, port number required, all the dependencies that were required to be considered. See, the best way to do is it. Now you saw my deployment.yaml file. Because I have trained the model, I know what are the packages required. One thing you can do is every data scientist can have their own Conda environment when they develop, or own virtual Python environment when they develop. And once they have developed the model, you can take all the required dependencies and then move it into your Docker file requirements.txt. Right, that is one option. One disadvantage of this is now a data scientist may install 30 packages, but he may use only 5 of it, because while we are experimenting, we tend to use a lot of packages, right? So that is one drawback of this particular approach. So the best way is to manually, the data scientist can just run it and validate in the environment. But if you're going big at Docker-based training, that's a good option, because you know basically what is the requirement or text file you used, and that you can replicate over here. Okay. So when I run my Flask, this is from Cyril. When I run my Flask application with GUnicorn local system, the log get printed. But when I deploy the application with Kubernetes, the log does not, when I check the logs of PAR. So what happens, like your GUnicorn is going to spin up a separate web server instance, right? So basically, see, don't use the print command. I'm not sure what you're using. Are you using your own logger and custom logger? And try to write that logger into your custom file rather than printing it on your Google Cloud console, right? In Kubernetes Cloud console. So when you write your own logger, you redirecting the output to your own custom logger, and you can see it. And that log, what you can do is you can use it to source to any like Grafana or Kibana, and then you can analyze the log. But with GUnicorn, because it spans a separate worker thread process, you may see that issue, because your Kubernetes on cloud logs might not have it. Okay. So that's, but if you're using a Flask application, it should get printed. Only with GUnicorn, you will see this problem. Right now, that's one thing, right? Whether you require a GUnicorn or not in your Kubernetes environment, it is all dependent, right? Say like if you are getting in each instance with very low cores and memory, each container is just like 0.5 cores, and basically you have very less memory, then you can just have a Flask application and do an horizontal scaling of your pods. But if your each container is pretty big, say you have like 5 cores and or it's 8 cores and you have like a lot of memory, then you want to run multiple worker process using gunicorn, so that you can within the container also you can like scale. But the only thing that happens is your round robin is still going to go to the container instances and then come to gunicorn, and within the container it's going to scale. So the architecture depends whether how you deploy it and how your Kubernetes and Docker configuration is. Okay. Now, the next question, when we code an application, we don't think that we will be adding in YAML file. How to design the YAML structure? Now, see, typically what you do is the YAML structure is going to be, see, the best thing about it, work with your MLOps and DevOps engineer, create a template YAML file, create a template Terraform file. That's where the MLOps investment comes into play. The MLOps infrastructure setup comes into play. Once you have it, depending on your deployment, you can just pick a template, whether you want a blue-green deployment, you want a canary deployment, or you just want to override it. And you can go and edit those template and then build your YAML file. That's how you typically structure it. Can we custom train easy OCR model? Any suggestions on how to do OCR? I know this is a different question altogether, but you can bring your own custom model to easy OCR, but I don't know how to do that, but you can use Keras OCR. In Keras OCR, you can train your own model. See, the Keras OCR and easy OCR uses the same architecture, Craft and CRCN, and I forgot the name of it, right? So you can use Keras OCR to do it, and you can do a custom training. I have a video where I have a custom trained model in Keras OCR and then embedded it, but I didn't cover the training aspect of it. I just covered like how to do it and how to deploy a custom trained model. You can check it out. Keras OCR, I have not trained a custom model because I never had a need to do that. But in Keras OCR, I have tried. The underlying architecture of both the model is pretty same. Keras OCR or this. Keras OCR is pretty good, highly accurate OCR model. Just for a lot of predefined tasks. Okay. Next question is from Venkatesh. How can we make say a particular layer to make it trainable rather than making entire feature? Now, in this case, in TensorFlow model, I don't think you have an option. I am not sure you have an option. So in that case, what I would suggest is you load the model like using just a non-TFUP. There's a TFUP classification also. I have not tried it, if there's a way to say that the layer trainable, but I would say like then go outside of TFUP, just import the Keras also provides you the pre-trained model. You can import it. You can go and select the layer that you want to train, and you can train it from there. Frankly, Venkatesh, I have not tried in TensorFlow, but you can do it with non-TensorFlow models. Okay. So the next question is, Abhilash, like I did not understand this question. Can we use the recent model as well? You can use any model. The example I showed is for TensorFlow, but you can use for any purpose. I even have like an Flask deployment of non-TensorFlow model, but can you elaborate on that, Abhilash? Maybe I'll answer that question as we come down. So yeah, I think somebody has answered to Venkatesh's question. What is this? Yeah, so I'm not sure you can do it with non-TFUP. I have not tried it with TFUP models. Okay, so next is, do you prefer saving format HFI? Consider the HFI is, so yeah, that is actually the HFI format is an old format of TensorFlow. It gives you only one object. That is pretty good. But I prefer the new model because it gives me a separate pre-processing step as well. And it gives me the graph, which I can do. I can even deploy this model in Java. That's the best thing, like, because sometimes you want to deploy a TensorFlow model in Java because your application is written in Java. I have not tried an HFI model in Java. So I would always prefer to be on the new format so that it's better, like the TensorFlow is able to better support it. Okay, so the next is, I think the previous one is complete. Let me quickly go over there and come to the remaining questions. So if you see like this step is completed, let me go to Kubernetes engine now and see if the continuous build also deployed. It says successful here, so there is no error over here. So let me go to the Kubernetes engine and let me go into the services ingress. Wait a minute. And let me open the URL now. And if it has deployed properly with the GitHub, you will see the Streamlit. Yeah, you're seeing this link. So the model is deployed. So even now with the continuous deployment that we did with CI/CD pipeline, it is deployed now, right? And that's what we did over here, the manual trigger, the continuous integration step. Okay, so let me go back to the questions now. How you trace the model metadata for governance audit purpose as you are directly deploying the model package from the local code, or you train again, capture metadata, and then deploy package. So see, the now this model metadata governance is a very vast subject, right? You're talking from what features I am bringing in and all this stuff. Now all this has to be more kind of a manual process, or you can use MLflow where you register your model metadata frequently and you create an more kind of a link later using that metadata to track it. Now for image, it will not be a big deal, right? Because in image, I have a set of data set which I'm using. But if you want to track the data sets, you can also track the data set version. So what you can do is when you're using a data set, say X, freeze the data set. Don't edit the data set after that. And put the directory structure, in my case for the image model, as part of my MLflow metadata, or I can use DVC to version control my data itself, right? So there are a lot of options available. And then in between in my model, if I want to print something, I can also put it in my MLflow tracking, and I can track all the things. Even my EDA I can track. There are a lot of things I can track. Even the model objects I can track, because I will be running hundreds of experiments. And each experiment may provide me a different results, the metrics and all. So all this I can track, and I can go and visualize in the MLflow UI and get the respective version run, and also the model data that it used. So you're just tracking the data. You can use the data to be tracked in a table itself, or you can use DVC to track it. Only thing, freeze the data so that you can track it. Okay. So I think it's straightforward to replicate. Yes, it is pretty much straightforward, Amarnath, right? You can run it on any environment because the Kubernetes YAML file is not changing. The Docker file is not changing. The other aspects are not changing. The only thing that changes is the cloud build.yaml. Okay. So the next question is, does GCP has inbuilt way to handle dynamic traffic to spread? It does not have an inbuilt way, but in your in your deployment.yaml and service.yaml file, you can control it, how you want to deploy it. You can even like route the traffic and everything. And that's true with any cloud provider as well. Okay. The next is, I think we can do this with Heroku also, so that everyone, yeah, you can definitely use any environment. I have not tried Heroku much, but I think Heroku also supports containers and all this stuff, and you can do it. Or you do not use container itself, you can use any serverless infrastructure and run it as well. In Google Cloud, there's something called App Engine, you can run it. The same thing is applicable. You can do that as well. So what happens when GCR repo is private? Does GCP take care to access without accessing token if you have an image in GCR but wish to deploy in Azure AKS? How do we specify access token? Anirban, that's a very good question, right? I don't know how we can do it outside. I think GCP provides APIs. GCP provides SDKs where you can access, and I think the access token should be visible outside of it. Frankly, I have not tried my GCR repo to access outside of GCP. In that case, what I would say is the better way to do it is you can also use the Docker Hub private repo, which we know we can access from any environment using the keys or using the password and username, right? Depending on the comfortability. I am sure that GCR should have, because it's just a repository, right? They should also provide that access. But frankly, I have not tried it. Okay. The next question is, when should I prefer EKS for deploying my application, and when to choose an EC2 instance and use K8s to deploy my app there? So okay, K8. When should I prefer EKS for deployment, and when to choose an EC2 instance and use? So you're asking about whether I manage Kubernetes or you want to run an your own Kubernetes cluster. Now think about it, right? Like it all depends on your organization strategy. Now there is no difference between running EKS or EC2, but if you want to have your own complete private virtual net, you want to manage your Kubernetes, you have administration to manage, maintain, upgrade Kubernetes and all this task, and your enterprise strategy is to have your own managed Kubernetes. Say if you have an OpenShift environment, you want to run an OpenShift environment on Amazon, right? So you can go with your own OpenShift. You can also have an hybrid cloud in that time. What can happen is part of your OpenShift environment can be on-premise, part can be on cloud. So you save cost. So you have an existing information infrastructure in on-premise. You are not going to throw away that, right? You are going to keep it, and you want cloud for only cloud bursting where there's a spike in traffic, or you want a GPU nodes, you can go into cloud. So you can, when you have your own control or your own Kubernetes engine, you have that control. If you're on Google, you have Google Anthos. Anthos is basically going to unify your cloud and on-premise. You can use that. So in AWS, that is AWS Outpost, but I am not sure on the maturity of the Outpost still for hybrid deployment, right? But I said that it all depends on your organization strategy. If you want to do hybrid cloud, if you want to do those kind of setup, you can have your own EC2. But if you want less administration part, you want to basically only worry about your deployment, not about administrating. You don't have a lot of people to manage a Kubernetes cluster, then EKS is more preferable. In large organization, typically you have a lot of people to manage it. You can do your own EC2 instance. Next is, thank you very much, MBF, for the compliment. Okay, the next one is, I think Rohit has replied. Yeah, scalability is there. Even with your EC2 instance, you can have a lot of EC2 instance running and you can do that. Scalability, yes, one part of it, because you don't have to worry about the infrastructure. You set up auto scale and you kind of get it over there, right? And thank you, Tejas, as well. So I think like there's a back and forth question. Let me go a little fast. I know we are on top of the hour. So the next question is, do Google have any inbuilt web application framework like Azure where you do not have to take care of creating a web application like you did using Streamlit? So I'm not sure of web application, but if you want to deploy this TensorFlow model in without building any framework, you can use Vertex AI prediction. If you go, one of my first video on Google Cloud is about using Google Cloud AI prediction, which is now called Vertex AI. You can deploy your TensorFlow model, scikit-learn model directly on that without creating any web application. Okay, so you can do that as well, or you can use TF serving as well. Tejas, GCP is not free, but you can get a $300 credit, which you can use. Okay, so that you can use. Next is, so based on the configuration. Okay, this again the question. I think there are, thank you, a lot of people, like you are answering a lot of questions, and that really makes my life easy so that I can pick only the questions that are not answered. Show us how you build cloud.yaml file. So if you really see that was in the video I showed you, like cloud.build. It's just a YAML definition, right? You just import the builders. In my case, the builders is Docker, Kubernetes, and Bash. Just for printing out, I'm using Bash. So you just import the builders and run the typical Docker command, what you do, right? In Kubernetes, you say Kubernetes kubectl run or deploy and everything. You just run that. Maybe you can come and watch my video, that section. It's pretty simple. It's just a YAML file definition. Now, the YAML file also makes it hard because you need to have the format. You need to know what it is. But if you go to the cloudbuild.yaml documentation, you have a lot of information. I'll try to see if I can deep dive into cloudbuild.yaml in a future session. Now, how can we add retraining pipeline to development? So retraining is a separate process altogether, right? Now, typically what you want to do if you're deploying on Kubeflow, or if you're having own Docker container for training, you want to retrain the model in a particular interval, or you want to retrain when there is a new model code checked in, or you want to retrain when the model has drifted altogether. So you are monitoring your model in production and the model has drifted. You want to trigger a retraining pipeline with the new data added. So that maybe I will cover in a separate session altogether, because the first part And here it is, right? I know a lot of people are today thinking about retraining pipeline and all. When you're defining an MLOps, I would feel like retraining is not the critical part of the pipeline, because you don't really retrain a lot of some of the models. You don't have to retrain daily or hourly or even monthly. In some cases, yes, you have to, but most of the enterprise application, your retraining happens only when the data or model get drifted. In some application, it may take year to drift. In some application, it can be a drift every day. So depending on your requirement, prioritize where you want to set your continuous deployment pipeline. But yeah, retraining pipeline I will cover in my future videos. Okay. What are the tools used for model management is such production training pipeline? There are a lot of tools for model management. You can use, if you're a SaaS model manager, you can use SaaS itself, you're a SaaS shop. You can build your own custom model management, but it becomes a glue of different sources that comes into play, right? It can be your ML flow, it can be DVC, or you have your own metadata management layer where you create all this model management stuff. ML flow is a good start because you can control what you want to manage and what you want to put over there. Okay. How to start up with Docker and YAML file. That is a pretty good website. I think katakonda.com, which takes you to Docker and Kubernetes YAML file. That's a good start. I also have a detailed session on getting started with Docker and Kubernetes, which you can refer. That is where you can see. But the Katakonda gives you a working environment where you can go along and you can do it. Okay. Next is, can we add manual triggers to deploy the same code on different, good, on, you different environment, right? You can do it. So what you do is, can we add multiple, different, okay, multiple triggers, you can add multiple triggers. I created only one trigger. You can create multiple triggers over there. You can even create triggers on a particular tag or branch. You can do that. Okay, sure. Okay. I think there was a rephrasing of the multiple triggers for a, you can do, actually, if you want to deploy on AWS and Azure using that, you can do that. Because if you see the last step that I'm doing, I showed you shell script. You can write a shell script. You can install AWS CLI or Azure local command line interface. You can call Azure and AWS, authenticate it, and deploy it over there as well using Google Cloud Build. You can do that, yes. Okay. How do we do MLOps on on-premise? So MLOps on on-premise, you can you create your own pipeline. You can basically put your code in Git or Bitbucket or something like that. And then from there, you can connect a Jenkins pipeline. The Jenkins pipeline will build a container for you. And then you can use some kind of mu deploy or any kind of deployment tool that will push this particular container into your Kubernetes cluster, or it can be your physical hardware as well, right? So you can do the same steps, but with a different set of tools. The question is, how do we integrate ML models with .NET application? I am sorry, Rajat, I am not familiar with .NET application. I can tell you with Java. In Java, you can do a lot of things. If you are using a XGBoost model, you can just take the model and then you can take the trees and then you can integrate it. You can use H2O to create an Java Mojo object or Pojo object. Or you can use Java TensorFlow to load a TensorFlow module. I'm not familiar with .NET. I'm sorry for that. Can we selectively run some commits? Not all. So selectively run some commits. I would say, see, the best way to do is, I think you can put a regex filter. I'm not sure of that, but the best way I would do it is, I will create I will not configure it to my main branch or dev branch. So what I will do, because the developers will be coming, there will be multiple developers who will be committing it. So what you can do is, at the end of the day, you can create a script that will move the code from the developer branch to any other branch. And in that branch, you can configure the cloud build so that at the end of the day it runs. That will be a better architecture rather than building intelligence into your pipeline on which commit you want to take and which commit you do not want to take. Can we say this full setup belongs to cloud native? So now this is native to GCP with the cloud build.yaml, but the before step of cloud build.yaml, the same code can run in any infrastructure, Azure, Kubernetes, or this one, or even your on-premise. So it is not I know it is a cloud, that the cloud native kind of these days everything is cloud native when you're running on a cloud. When you say cloud native, the Kubernetes itself is a cloud native foundation, right? You can run native components on it that is not tied to on-premise or cloud. Yes, it is, but the last step is applicable only for GCP. Okay. So kubectl is just a command line utility. Minikube is an mini Kubernetes environment for you that you run Kubernetes. In Minikube also you will use kubectl. Kubectl is your command line utility to run, deploy, manage applications on Kubernetes. How do we keep monitoring the model, like to check for data drift and accuracy drop? So glad, like I have a video on model monitoring. You can check that out. What you can do is see when you're training a model, you have a set of distribution of data and the distribution of predictions. Now, what you do is you have on the real-time infrastructure, you get data and you will get a distribution of that. So you keep comparing the distribution with some statistical technique like KS stats or KL divergence or population stability index, and then see if there's a drift in your model or data, and accordingly you take actions, right? But you can check my other video where I have detail on that. Yes, you can use Cloud Code. You can do that. Okay, I think this is the final question that I will take, and this is the final question. In fact, deploying model in IIS servers, is there any more latency it causes? So Rajat, again, IIS server is specific to Microsoft implementation, but see, we have deployed this model in Java in a Tomcat server, and it all depends on how you tune your Tomcat memory and your like you are using Nginx or something, how you are putting the server and you are kind of caching your incoming request, turning it, whether you are using gunicorn, Flask and all. So all this matters at that time when you are running on local. But no, you can fine tune any model on any infrastructure to your latency. There's a huge engineering effort that goes into it. It's not like only cloud will give you better performance or Kubernetes give you better performance. You can get better performance in your server as well, right? So yes, you can do it. I'm not sure about IIS server, but we can do it on Tomcat, or we can do it on any other web server if it's a Java-based application. Okay. And thank you very much. Thank you, Kishore, as always. And I hope you have a very good rest of the evening or rest of the day, depending on where you are. Thank you all very much. Thank you.